Okay, so we're looking at 10. We're going to try and graph this like we normally would. So the vertex would be where? Negative 1, 4. And how would I graph the rest of it? Right, I have a slope of negative 2, so I'm going to go down 2 to the right 1, down to the right 1. And then the same thing to make the back side, but I go down 2, left 1. Okay? So if I'm trying to turn this into piecewise, where does my graph split? At negative 1. So this side, this line here, will exist when x is less than 1. Negative 1, sorry. And then this piece will exist when x is greater than or equal to negative 1. I know I've said it 10 times, but just for the sake of the video, one of these two has to have the or equal to bar underneath. You don't want to have both of them without it, because then you would have an open circle, a hole right there at your vertex. So one of them has to have the bar underneath. It doesn't matter which one, it's up to you. So let's see, can you figure out the equation of this line? It looks like it has a slope of positive 2. Where would, yeah, 2x plus 6. If it were to continue, it would have hit the y-axis at 6. And this right-hand branch? You got it. Pretty good? All right. One nice thing about the absolute values when you do them like this, your slope should always be opposite of each other. So one's positive, one's negative, but it should be the same value. So that's a quick check. Make sure you're sort of in the right ballpark. Okay, let's do one more. Anybody have a preference from 7 to 12? 9, I hear. Okay. Where would your vertex be? 0, 2. And then we have a slope of 3. So f of x equals, one part of my graph lives where? When x is less than 0. The other one will exist when x is greater than or equal to 0. Okay, when it's less than 0, what's the equation of that line? Negative 3x plus 2. And the right-hand branch? Yep, there you go.